I would like you to consider this interesting graph here, and I want you to imagine what this graph would look like if it was rotated. This peak would go there, that peak would come here. This intersection would go here, and this intersection would come here. This shooting up would go to the shooting down here, and this shooting down would go to this shooting up here. I think it would overlap right on top of itself. What do you think? We'll find out. So shall we plot negative f of negative x. Let's see what happens. Alright, indeed, it covered itself exactly on top. Well, in fact, it covered so well that it's hard to see. So why don't we lift it just a little bit so that we can tell ourselves that indeed there is a blue one lying underneath here. Indeed there is. So what is this type of function called that just covers itself when you rotate it? Let's get rid of the shifting to make the effect more complete. Look at that. It's just completely on top of itself. This is called odd function. Why is it called odd function? Because the power is odd. Let me show you here. If I take this, paste it here, and I will expand it for you. Not that I'm doing it, Mathematica is doing it. Here we go. You see? First power and third power. There is no constant, there's no even powers. So when you have all the powers, when all the powers are odd, then this is what you get. You get all kinds of different graphs, but the result is that you get something that just rotates on itself. That is, it is an odd function. Now let's construct an odd function ourselves. All odd functions will go through the origin. Think about that, why it has to do it. Alright, let's see. I will say something like this that I came up with. Okay, now this got to be an odd function, so I got to just perform here, right? This peak is here, and this is would go here, right? So it would be something like this. Then I got to go across here, which is 1, negative 0.3, so negative 1, positive 0.3. It was too high. So it's here, and then let's see. I got to dive into what? 1, comma 1.2. So negative 1, comma negative 1.2. That's where I go. Make a sharp peak and pass slightly past 2. So make a sharp peak and past 2. Okay, and then I got to dip under, and at 2.4 I'm dipping 0.5. So at 2.4 I'm dipping 0.5. There it is. And then I'm passing, turning around and passing through 3. Did that, and then I go up as high as at 3.4. I go as high as 1.7. 3.4, I go 1.7, 3.4, 1.7 here. Here we go. Then I turn around. I kind of regret I'm making such a complicated one, passing through 4. And then goes all the way down 2. So up 2 past that here. Okay, it's not satisfying. This peak doesn't seem to match here. But more or less I created this odd function that is supposed to be an odd function. Let's find out if it is. Here is the moment of truth. I made a copy of it, and then I'm going to rotate it to see if I can match where it came from. So if I did a good job, it should match the original one. Well, you be the judge. How was I? Now, and also answer this for yourself. How better are you? Can you do this? Yes, you should do it to find out. So this is the odd function. When you rotate like that, what I just did, it would look the same. If that's happening, it's called an odd function.